Dear Bhumika,
Yes, sir.
yeah, so now let's start our new topic for today is that
Okay.
we are going to discuss about the factor theorem. So far we
Okay.
have discussed, division algorithm, remainder theorem in the last class, correct? And
Sir, you
also,
had given me one more question.
okay, so let me complete this one. After that, we'll discuss that. Okay,
Okay, sir.
sure. So let me complete this topic first. After that, we'll come to that question, correct? I
Okay,
do
sir.
remember. So that is a question on remainder theorem, correct? No?
Factor theorem.
Factor theorem, yeah. So let's discuss the factor theorem in details, correct?
Okay, sir.
So what is mean by the factor of a polynomial? What is meant by the factor of a polynomial? So if you recall that while we discussed about the, uh, about the remainder theorem, and before that when we discussed about the division algorithm, one thing we understood is that, so let me write the topic name first. Okay, so if you recall that from the division algorithm, we get fx equal to phi x into psi x, correct? No?
Yes, sir.
Plus rx. That means if we divide fx by phi x, that means what? If we divide fx by phi x, then psi x is the quotient. This psi x, what you see, let me use a different color. So what you see that psi x, that is known as the quotient, correct? No?
Yes, sir.
This is known as the quotient. And this Rx, what you see, this is known as the remainder. Correct? Quotient and
Yes.
remainder. Now, if Rx equal to 0, then what we can say? We can clearly say that fx is divisible by phi x. Correct or not?
Yes, sir.
If Rx, if any division, if we get after division, if we get the remainder 0, so what we can conclude? We can conclude if Rx equal to 0, this implies fx is equal to phi x into psi x. Correct or not, dear student? Clear or not
Yes.
clear? Absolutely clear, no?
Yes, sir.
Great. Now the point is that the moment we see this thing, that fx equal to phi x plus into psi x, that implies what? From this information, what we can conclude? We can conclude that phi x and psi x are factors of fx. Correct or not? From this
Yes, sir.
information, we can conclude that phi x and psi x are factors of fx. Clear or not clear? Absolutely clear.
Yes, sir.
Okay.
Yes, sir.
So whenever you find, whenever you divide one polynomial expression by another polynomial expression, and if you get the remainder, then you can say this thing, that whatever the quotient you got and whatever with which you divided, both are factors. Okay. You take an example. Okay. Suppose let's take an example. Fx equal to, we take fx equal to, for example, x square minus x minus 12, x square minus x minus 12, and let's take that phi x and we take phi x equal to, x minus 4. That means what? We are going to divide x square minus x minus 12 by x minus 4. Correct, no?
Yes, sir.
We divide x square minus x minus 12 by x minus 4. What you will get? You will get the remainder 0. If you make a long division, you will get the remainder 0. Okay, there are two ways you can do it. You can just simply, divide, x minus 4. Okay, here you write x square minus x minus 12. Correct, na, dear student? So
Yes,
here you write x. So here you get x square minus 4x. And here it will be plus, here is minus. So plus 4x minus x become 3x and minus 12. So we multiplied by 3. Okay, so then quotient become 3. Then we should multiply here 3x minus 14. 12, sorry, 3x minus 12. Correct, no? And then
yes,
it
sir.
plus, it becomes minus, and finally you get the remainder as 0. So what we get? We get x plus 3 is the quotient and remainder is 0. So what we can write from here? We can write, that fx, that is equal to x square minus x minus 12, that should be equal to x minus 4, that is phi x. Correct, na? That is equal to
Yes, sir.
x minus 4, that is phi x. And what is psi x? Psi x is the quotient, that is x plus 3. Correct, na? So what we can say? We can say that both x minus 4 and x plus 3 are factors of the quadratic polynomial x square minus x minus 12. Correct or not?
Yes,
So here what we can say is that x minus 4 and x plus 3 are factors of the quadratic polynomial x square minus x minus 12. Correct or not?
yes, sir.
Minus x minus 12. So this is the way we find the factors. Correct. Now what is the factor theorem? Okay. Factor theorem is that, if we have this polynomial, okay, and for a particular value of x, so in this case, if you see that when we see that when we are dividing fx, let me use a different color. Let me use a different color and just explain once more. Suppose fx is a polynomial now, and you are dividing fx by x minus 4. And what we see? We see that when you divide that x square minus x minus 12, which is fx, by x minus 4, which is 5x, we get the remainder 0. Correct. And from there, what we can conclude that yeah, x minus 4 is a factor. X plus 3 so is a factor, but x minus 4 is also a factor. In the same manner, Bhumika, if you divide that x square minus x minus 12 by x plus 3, then also you'll get the remainder is 0. Correct, no?
Yes, sir.
Now, what happened is that what we are going to get is that if we start finding the value of f4, what we'll get? We'll get the value of f4. Let's see. 4 square minus 4 minus 12. That is equal to 16 minus 16, na, dear student? That is equal
Yes,
to
sir.
0. So what we get? f4 equal to 0. Now, if we get f4 equal to 0, that means we can say that x minus 4 is a factor of the polynomial x square minus x minus 12. Got it, no? Let me
Yes,
read.
sir.
What I'm saying is that whenever a polynomial expression is asked to divide is divided by another polynomial linear expression like x minus 4, and you start finding the value of the polynomial which is getting divided, okay, for that value of x equal to 4 in this case, and if we get 0, we say that definitely x minus 4 is a factor of the is a given polynomial. Okay, similarly, let's what you got, x minus 4 is a factor and x plus 3 also is a factor now. So if we find the value of f of minus 3, then also you should get 0. What is that? It is 3 minus 3 whole square, correct no? Minus of minus 3 minus 12, correct or not?
Yes,
So
sir.
minus 3 whole square is 9, minus of minus 3 is plus 3, and minus 12. So 12 minus 12 is 0. So that is the foundation of the factor theorem. So what factor theorem says in simple term is that if for a particular value of a function, okay, if we let me write it down, then it will be very clear about the factor theorem. Okay, so let me take a new page to explain you the factor theorem. So what factor theorem says that, okay, suppose we have a polynomial fx, okay, suppose we have a polynomial fx. If f of alpha is equal to 0, that implies x minus alpha is a factor of fx. Okay, I'll explain this thing with by means of the both theory and example. And the other way, okay, the converse is that if, okay, x minus alpha is a factor of fx, if x minus alpha is a factor, just a minute, let me write properly, is a factor of fx, okay, that implies, you know, f of alpha is equal to 0. Both are true. If f alpha is equal to 0, then you can say that x minus alpha is a factor of fx. And on the other way, if you see that if someone is telling you, hey, x minus alpha is a factor of a polynomial fx, then you can conclude that, okay, f alpha has to be 0. Clear or not clear? I'm going to
Yes, sir.
clear. Okay, great. I'm going to establish that one. That how come we get this one? Think about that. Let me use a different color. That you are dividing a polynomial fx. We are dividing a polynomial fx by x minus alpha. Then what will get? It is x minus alpha into we get qx. Suppose qx is the remainder, and plus r, that is the sorry, qx is the quotient. I'm so sorry. Qx is the quotient and r is the remainder. Let me repeat. Suppose there is a polynomial fx and you are dividing that polynomial fx by x minus alpha. So what we get? You will get fx equal to x minus alpha into qx plus r, where qx is the quotient and r is the remainder. Clear or not clear?
Yes,
Absolutely
sir.
clear. Okay. Now what we
Yes,
are going to
sir.
do is that, okay, now let's apply alpha in this equation. Okay. If at so this implies what? This implies f of alpha is equal to alpha minus alpha into q into x, q into alpha, plus r. Correct or not? So this
Yes,
implies
sir.
what? This implies f of alpha is equal to r. Correct or not? So now if r equal to 0, that means if f alpha equal to 0, that means what? Now after that, if r equal to 0, that is if alpha equal to 0, then what we are going to conclude? So we are going to conclude from here is that we are going to write fx equal to x minus alpha into q alpha qx, correct or not, plus 0, correct or not?
Yes, sir.
That implies what? That implies fx is equal to x minus alpha into qx. That implies x minus alpha is a factor of fx. That implies x minus alpha is a factor of fx. Correct or not?
Yes, sir.
Absolutely clear, or any doubt you have?
Clear, sir.
So the fundamental is that the basic thing is that if any polynomial is given, to you and it is asked whether verify whether x minus alpha is a factor to that polynomial or not, what you will do, you simply apply the value of x as alpha in the given polynomial. If you get the value after applying the value of x equal to alpha in the given polynomial, then you can absolutely say yes, x minus alpha is a factor to the given polynomial. If it is not equal to 0, then you say no, it is not a factor to the given polynomial. Let's take an example. So what I have explained so far, the theory, factor theorem, and also factor theorem is explained here. Sorry, let me use a different color. Factor theorem is explained here, and how this factor theorem came, I just explained in the blue color below. But what I'm going to do is now very important statement as long as the your numerical problem is concerned. So let's take an example. So prove that. So if this is a question, prove that x plus 5 is a factor of 2x square plus 7x minus 15. Let me put it here. Just give me a minute, please. So what is the question here? Prove that x plus 5 is a factor of 2x square plus 7x minus 15. Correct, no? So how to approach?
Yes, sir.
Yes. So what is fx here? Fx is equal
2x
to,
square plus 7x minus 15.
very good, 2x square plus 7x minus 15. Now, what is the alpha here? Could you please tell me what is the alpha here? We are dividing by x plus 5.
Minus,
Very good.
minus 5.
Fantastic. Appreciate. So x plus 5, always you need to express in terms of minus. So x minus of minus 5. Fantastic. So then what we are going to get? Let me write 5 properly. Then we are going to find the value of f of minus 5. We'll find the value. Now, dear student, if we get the value of f of minus 5 equal to 0, then it is proved that yes, x plus 5 is a factor of this. If it is not, then we can say two things. Either we have done something wrong in our calculation or the question is wrong. Got my point, no?
Yes,
So,
sir.
what we are going to do is that 2 into minus 5 whole square plus 7 into minus 5 minus 15, correct? So 2 into minus 5 whole square, minus 5 whole square is what, 25? 25 into 2 is 50, correct, na? 50 minus
Yes, sir.
into 5 is minus 35 and minus 15. So 50 minus 35 minus 15, that is 50 minus 50, correct, na? That is equal to 0.
Yes, sir.
So that means, yes. So as f of minus 5 equal to 0, so what we can write? As f of minus 5 equal to 0, we can conclude that x minus of minus 5, sorry, x minus of minus 5, that is x plus 5, is a factor of 2x square plus 7x minus 15, correct, na?
Yes, sir.
Absolutely clear or any doubt? Okay.
Clear, sir.
Okay, great. Let's take another one because these are very, very important. And let me tell you, in future also it will be so important when you will be, you know, uh, you know, solve problem related to, quadratic equation or theory of equation. Later, we can we can find this thing very, very important. Okay.
Okay.
Okay. Another side discussion I can tell you that also you should remember very well is that and that is ax plus b is a factor of fx. Ax plus b is a factor of fx if f of minus b by a is equal to 0. Got it? If f of minus b by a is equal to 0, then we can say that ax plus b is a factor of fx. And converse is also true. And what we can say, if we get f of minus b by a is equal to 0, then we can say that fx has a factor f(ax plus b). Then what we can say? Then we can say fx has a factor ax plus b. Clear?
Yes, sir.
Okay, great. So for example, let's take an example. Okay, for example, let's take verify that 2x minus 1 is a factor of 6x squared plus 11x minus 7. So let me place the question. So we need to verify this thing, by the way. Verify that 2x minus 1 is a factor of 6x square plus 11x minus 7. So what is our fx here? Fx is 6x square plus 11x minus 7. Na? Then what is
Sir.
the value we are going to find? F of 1 by 2, correct or not? Clear or not clear?
Yes, sir.
Because 2x minus 1, na?
Clear.
A plus b, yeah. So f of minus b by a means f of 1 by 2. So if we find 6 of 1 by 2 whole square plus 11 into 1 by 2 minus 7, that is equal to 6 into 1 by 4, that is 6 by 4. 6 by 4 plus 11 by 2 minus 7. And let's find this value. And you'll find the value is equal to 0. You can compute this and you will get the value is equal to 0. Shall I solve how it is? Okay, let me do it then. So this value you are going to get 6 by 4 is equal to 3 by 2 plus 11 by 2 minus 7, that is equal to 2 become the LCM, 3 plus 11 minus 14. So 3 plus 11 is nothing but 14, correct? No? So that is equal to 14
Yes.
minus 14 divided by 2. So that is equal to 0 by 2, that is equal to 0. So whatever the problem we need to solve problem, very confidently. Okay. So
Yes, sir.
let's solve a couple of problems. And the next statement, what I'm going to make, it is quite obvious, is that, if you consider, as we already discussed about the quadratic equation, right? So if you
Yes,
recall
sir.
that from the knowledge of quadratic equation, what we can say is that if if for a quadratic equation, if for a quadratic equation ax square plus bx, let me write properly, equation ax square plus bx plus c, if for a quadratic equation ax square plus bx plus c equal to 0, okay, let me reframe the statement. If the quadratic equation ax square plus bx plus 0 c plus c equal to 0, let me repeat the statement once more, dear student. If the quadratic equation ax square plus bx plus c equal to 0 having roots alpha and beta, what we can conclude, you know, we can conclude that x minus alpha and x minus beta are factors of ax square plus bx plus c. Did you get my point? In the quadratic equation ax square plus bx plus c equal to 0 having roots alpha and beta, then we can conclude that x minus alpha is a factor of x square plus bx plus c, and x minus beta is also a factor of ax square plus bx plus c. Okay, same thing is true for the cubic equation as well. Are you getting my point, what I'm talking, dear Bhumika?
Yes, sir.
Hmm?
Yes,
Okay.
sir.
So what you can write is that x minus alpha into x minus beta. So we can write in fact we can write ax square. In fact, we can write ax square plus bx plus c as a into x minus alpha into x minus beta. Same concept is applicable to cubic equation. That means what? Let me write for the sake of completeness. And all these things, you know, dear Bhumika, you need to write in your notebook also. I'll send you the class notes after the class, and you need to take it all these things and make your own personal note as well.
Okay, sir.
So if the next statement what I'm going to make, if the cubic equation, if the cubic equation ax cube plus axs cube plus bx square plus cx plus d equal to 0. Okay, having roots alpha, beta, and gamma, because it's a cubic equation, so it can have three roots, correct now? So
Yes,
from here,
sir.
what we can conclude? We can conclude x minus alpha, comma x minus beta, and x minus gamma are factors of ax cube plus bx square plus cx plus d. Clear or not clear?
Clear, sir.
We can write in other form is that ax cube plus bx square plus cx plus d equal to a into x minus alpha into x minus beta into x minus gamma. Okay, so let us take some examples so that it will clear our ideas. Okay, so I think
Okay, sir.
one question I gave you in the last class, that I think you are talking about this one. Please clarify if it is not. If 4x square minus 1 is a factor of 12x cube plus px square plus qx minus 1, is it the question you are talking about?
No, sir.
Okay, so which question you are talking about then?
What number should be subtracted from
Oh,
x square plus x
that
plus
that
1?
that, that you have done correctly, no? That you get the value 7, right? Or if you want me to discuss, I can discuss this question also.
Yes, sir.
Shall I
I got the answer.
Yeah, it is correct. I know. So that's why I didn't discuss this one. So let's work on the next problem together. Okay.
Okay, sir.
So I'm going to share the question first, and then we'll start solving together. And let me go to the next one. Next page. So what is the question? Question is that if 4x square minus 1 is a factor of 12x cube plus px square plus qx minus 1, we need to find the value of p and q. Correct, no?
Yes,
Oh,
sir.
so let's start solving. Let me solve it. You can also work with me. Open your notebook and start solving. So
Okay.
the moment you see this thing, first we need to write what fx. Which one is fx? Tell me.
12x square
Where
plus
12x
px
cube, 12x cube, 12x
12x
cube
cube
plus px square plus qx minus 1. And this fx is getting divided by what? 4x square minus 1. So 4x square minus 1, that implies what? It is 2x whole square, na? Minus 1 square. Correct or not? So 2x minus 1 whole, 2x whole square minus 1 whole square. That means 2x plus 1 into 2x minus 1. Correct?
Yes, sir.
So as 4x square minus 1 is a factor of fx, according to the question, what is given? According to the question, according to the question, 4x square minus 1 is a factor of fx. Correct or not?
Yes, sir.
This implies 2x plus 1 into 2x minus 1 is a factor of fx. Correct or not?
Yes, sir.
This implies 2x plus 1 is a factor of fx, and 2x minus 1 is a factor of fx. Factor of fx. Correct, no? Now let's
Yes.
focus on this particular statement. 2x plus 1 is a factor of fx. So from here, what we can conclude? We can conclude that f of minus 1 by 2 is equal to 0. Correct or not?
Yes, sir.
Absolutely clear?
Yes,
And
sir.
when we say that 2x minus 1 is a factor of fx, from here what we can conclude? F of 1 by 2 equal to 0. Clear or not clear?
Yes, sir.
Now when we say that f of minus 1 by 2 is equal to 0, so we just apply the value of x equal to minus 1 by 2 in that expression fx. Correct or not?
Yes,
So
sir.
as you see here, this is the fx na here. So what we get from here? From here we get 12 into minus 1 by 2 whole cube plus p into minus 1 by 2 whole square plus q into minus 1 by 2 minus 1 is equal to 0. Correct or not?
Yes, sir.
And here also what we get, that as f of 1 by 2 is equal to 0, so we get 12 of 1 by 2 power 3 plus p into 1 by 2 power 2 plus q into 1 by 2 minus 1 equal to 0. So if you look into the first one, that p into minus 1 by 2 whole cube, you know, and plus p into minus 1 by 2, okay, sorry, q into minus 1 by 2 and minus 1. From there we get one equation, correct or not? And what are the
Yes,
equations
sir.
we'll get? We from here, if you simplify, so that simplification I'm not telling it here because that simplification is straightforward and not a part of the discussion of our present class. Here we are discussing about the factor theorem. So if you simplify, you will become p by 4 minus q by 2 and minus 5 by 2. That is equal to 0. This is one equation you get. Correct, no, dear student?
Yes, sir.
And once you look into this one, from here what you get, if you simplify, I'm just writing the simplified form, that is p by
Okay.
4 plus q by 2 plus 1 by 2 is equal to 0. Correct? Now, once we start
Yes.
solving these two equations, you will find the value of p and q. And that is a linear equation. Okay? So you start solving these two values, these two equations, and what value you get, you will get the value of p is equal to 4 and q is equal to minus 3. And that is the value of p and q we are supposed to find based on the question, correct? And we are able to find it out. Is it
Yes, sir.
absolutely clear? Did you understand each and every point? Hmm?
Yes, sir.
Okay, great. Fine. Then I would like to give you one question and I want you to solve it. Okay? Take
Okay, sir.
a couple of minutes and solve it. And after that, you do let me know that whether you're able to do it or not.
Okay, sir.
Find the roots of the equation, hence factorize. Is the question clear?
Yes, sir.
Please take a couple of minutes and then solve it.
So the roots are imaginary. Minus 34.
Is it? Is it?
Yes, sir.
Okay. Could you please send me your solution? If it is a
Okay.
neat and clean work, can you please tell me your solution? 2x square minus 7x plus 6 equal to 0.
So that it b square minus 4ac
Yeah,
I
do
like
it.
that.
No problem. You can do b square minus 4ac.
Sir, 1 second, I'll send it.
Yes. But the roots are not imaginary, I can guarantee you. It is not. If you are able to do factorization, always prefer factorization. Okay. If you are not able to do factorization, then it is different. Then you should use the approach of b square minus 4ac. Okay. So let me help you. You can send it to me. I look into it.
Sir,
But
I didn't do factorization.
huh?
I I used only that for finding the discriminant and
You can do
to
this
find
again.
whether it's lesser than 0 or
Absolutely. But what I'm talking about is that from this one, we can solve this one. We can find the roots using middle term factorization. What I'm talking about? We can from here we can write this thing. Na? What is middle term factorization? That you should multiply 2 and 6, correct?
yes, sir.
2 and 6 is what? Multiply 12. So 12 has to be, expressed as a product of two numbers whose addition and subtraction will give you the middle one, that is minus 7. So 3 and
Yes,
4 are two factors of 12, and minus 3 minus 4 gives minus 7. Na? So minus 3x minus 4x plus 6 equal to 0. Correct or not? So from
yes,
here
sir.
what we get? From here we get x common, then you get 2x minus 3. And from here you get minus 2 common, then is 2x minus 3. Correct, na? So from
Yes,
here what
sir.
we get? 2x minus 3 we can take further, you can take common 2x minus 3 and then you get x minus 2. Clear or not clear? So from
Yes,
here
sir.
what you can write, either 2x minus 3 is equal to 0 or x minus 2 equal to 0. So this implies either x is equal to 3 by 2, this is one root, correct or not?
Yes,
Or x is equal to 2, that is another root. So these are the two roots, no? One is 3 by 2 and one is 2, correct? Clear or not clear?
clear, sir.
Very good. Now, hence factorize. The question is that the moment you start finding the roots, so factorization become very simple. So how to factorize this one? We already found its roots are its as corresponding equation roots are 3 by 2 and 2. So it should be 2 into a into, right, x minus alpha, that is x
Yes,
minus 3
sir.
by 2 into x minus beta, that is x minus 2. Correct or not? So that is equal to
Yes,
what?
sir.
2 into x minus 2 into x minus 3 by 2. So that is equal to 2x minus 3 into x minus 2. That is the factorization. Clear or not clear?
Clear, sir.
You can use, so now you can look into that the way you found the roots as imaginary. Definitely there is a mistake happened during the calculation of the discriminant. Got it?
Yes,
Definitely some mistake must have happened. Clear or not clear? Okay,
clear, sir.
great. Now let's solve next problem. Let me give you the next problem. It is a simple thing, factorize. So your first target should be that always using the middle term factorization. If you are not able to make middle term factorization, then you need to take that approach. What you are saying is that, using the discriminant, that minus b plus minus square root of b square minus 4ac by 2 into a. Correct or not?
Yes.
Take a couple of minutes to solve this one. In the factorage, what are the two factors you need to find out? So 3 plus root minus Yes, please. 3 plus.
root of 42 and root of 32.
Yes. So first one you get, 3 plus 3 root 5 by 2, and the second one is 3 minus 3 root 5 by 2. Correct, no? Hello? Hello? Hello, able to hear me?
Yes.
Yes, exactly. What you are saying is correct. So the two factors, what we get is, one is that you can first find the roots of this equation, and the roots what you get if you take this one, x square minus 3x minus 9 equal to 0. What will find the value of x? You will get the value of x is equal to 3 plus 3 root 5 by 2, 3 plus 3 into root 5 by 2, and the other one is that 3 minus 3 into root 5 by 2. These are the two roots. No? As we get the two roots, so it is very easy to factorize. So its factorize should be, x minus 3 plus 3 into root 5 by 2, and x minus 3 minus 3 into root 5 by 2. Correct, no, dear students? Got it? Okay. With this, I'd like to conclude the class for today. And before I'm concluding, I'd like to give you some assignments. And these assignments, I'm going to send it to you right now. Okay, so I'm going to give the assignments to your students now.
Okay.
Correct. And you need to solve all this before we start our next class.
Okay, sir.
Okay. Just a minute. Let me give you a few more. So these are the 11 questions you should do. And in the next class, we will solve some more problems from this one, and and we'll conclude this particular unit. Okay,
Okay.
so with this note, I would like to conclude the class for today. If you have any specific question for me, let me know. Otherwise, we can conclude the class now. Okay,
No, sir.
all right. Thank you.